Example 6, x squared plus 13x plus 36. Okay, there's not a common factor. The problem is written in the correct order, descending order. My leading coefficient is an understood 1. Okay, so we can still use the same properties, same rules that I've shown you on the previous examples. 1 times 36 is 36. Make a list of the factors, which would be 1 times 36, 2 times 18, 3 times 12, 4 times 9, or 6 times 6. From that list, okay, I'm still looking for the two numbers that will combine to be positive 13. Now, we said before, this is a positive 36. That means I want the two numbers that will add to give me the 13x. Okay, so that would be 4 and 9. Attach x to those two numbers. So I would write 4x and 9x. Divide by the leading term in my problem, which is x squared, and then reduce, just as we did on the other problems. When I reduce, I still have 4 in the numerator. X over x squared would be x. 9 would still be in the numerator. X over x squared is x. Okay, bottoms up or bottom to top, write the two binomials, x plus 4 times x plus 9. And what's just a little bit different about this problem is that the two numbers I found over here in my list happen to be the exact same numbers that I have in my answer. And that's going to happen when you have a leading coefficient of a 1. Okay, so that's always going to happen with those types of problems, but we can still work these out, exactly the same way as we've done all the other trinomials. Okay, looking at number 7, we have y squared minus 6y minus 27. There's not a common factor. The problem's written in the correct order. The leading term is the understood 1. So 1 times negative 27 is negative 27. Make a list of the factors of 27. 1 times 27 or 3 times 9. Now, because this is a negative number, that means I want the two numbers that will subtract to equal negative 6y. Okay, so that would be 3 and 9. If I subtracted those, you have to figure out the correct sign to go with your number. Okay, the higher number will always take this middle sign. So I need the 3 positive, the 9 negative, and we will attach the y, which is the variable in the problem, to those two numbers. So I would have 3y and negative 9y. If I combine, that would be negative 6y. Divide by the leading term, which is y squared, and then reduce. Okay, 3 over y when I reduce here, negative 9 over y when I reduce here. Okay, bottoms up or bottom to top would be y plus 3 times y minus 9. Okay, any of these, if you would like to, you can check by multiplying these back together using the FOIL method. That is a good way to make sure that you have your signs correct. Okay, let's look at example 8, 5x minus 14 plus x squared. Okay, there's not a common factor, but this problem is not in the correct order. Okay, so before you just start multiplying, you have to make sure that your highest degree term is first, so that would be the x squared, then my next degree, which would be the 5x, and then the constant, negative 14. Okay, so I would have x squared plus 5x minus 14. Again, multiply first coefficient times last. So 1 times negative 14 is negative 14. Make a list of the factors of 14. And because it is negative, I want what's going to subtract to give me positive 5x. Okay, so we know it's going to be 2 and 7. Get your signs correct. The higher number takes the middle sign. So that means the 2 is negative, but the 7 is positive. Attach x. Those are the two terms we're going to use. So I would have a negative 2x and a positive 7x. Divide by the leading term, x squared, and then reduce. Okay, negative 2 over x and 7 over x. So bottom to top or bottoms up, when I write my answer, it would be x minus 2 times x plus 7. Okay, do you see what I'm talking about here now when I say that my answers or my answers in my binomial match up to the same numbers? Okay, that only happens when my leading coefficient is a 1. That's not going to happen for the problems that have other numbers other than a 1.